Good day, everyone. I am Sir Robbie, and together, we will learn the word of the future, robotics. Did you know that here in Educational Technology Unit, robotics is a priority to make every Filipino learners and teachers competent and meet the demands of the future global scene? Wherein teachers, students, and parents who wanted to learn robotics is just a click away for free. Robotics is an interdisciplinary field which integrates computer science and engineering. It involves design, construction, operation, and use of robots to assist human activities. Are you ready for this transformation? Soon in ICT's Educational Technology Unit. Come and join us and love the future para sa bata, para sa bayan, at para sa guro. Sulong edukalidad.
Magandang araw, Sir Wilbur po, at your service. Narito ang ETUlay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETUlay ay isang free online tutorial class na pinangungunahan ng ICT's Educational Technology Unit sa pamumuno ni Undersecretary Elaine Del B. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETUlay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Magandang hapon po sa lahat ng ating mga taga-subaybay dito sa ating ETUlay session. Welcome to our last session for the school year 2020-2021. Tutor Lester po, at your service. So, gaya po na sabi ko, we are on the final week of the school year. And for this final week, we will discuss the general theory of relativity and how we know we live in an expanding universe. So for our last session, our objectives are the following. First, explain the consequences of the postulates of the general relativity. And lastly, explain how we know that we live in an expanding universe which used to be hot and is approximately 14 billion years old. So let us review some of the concepts na na-discuss po natin last week on the effects of the special theory of relativity. So please supply the missing letter in order to correctly name the concept. Right, the faster you move through space, the slower one moves through time. And this is all right. So the concept is time dilation. An observer at rest would observe a moving object's length to be shorter than its proper length. Ito po ay alright, length contraction. This is the cosmic speed limit. Nothing goes faster than it. And this is the speed of light. All right. So, as I have said, ang topic po natin sa session na ito ay ang general theory of relativity, and this will be followed by how we know we live in an expanding universe. So, let's get started with the general theory of relativity. So, let's start our topic or discussion on general theory of relativity by comparing kung ano po ang nagagawa ng bigat natin if we try to rest on our bed mattresses. So imagine we are from work at dahil pagod na pagod po tayo sa work ay una po nating pinupuntahan pagdating na bahay ay yung couch natin na gaya ng nakikita nyo. So dahil po sa taglay ng lambot ng bed mattresses natin or couch, talagang mas pipili natin mahiga dito. So, our weight pushes the couch or the mattresses downward. So, the theory of Albert Einstein na tatalakayin natin ay may kukumpara natin dito sa mattresses na ating hinihigaan. So, let us review the two postulates of the special relativity theory. Okay. The relativity postulate. So, ang unang postulate ay ang relativity postulate. So, ayon dito, all laws of physics are the same in all inertial frames. So, nakaupo ka man, nakatayo, o kaya nasa loob ng eroplano o kotse, the laws of physics remains the same. Para mas malinaw po kung bakit pareho ang laws of physics sa postulate number 1, let us imagine ourselves if we have ever been in an airplane as a passenger. So, yun po nakasakay ng aeroplano. Alright, so imagine yourself taking a plane to a destination. So, usually, before the plane takes off, we go to the comfort room to do our thing before the plane takes off. So take note, hindi pa po lumilipad yung eroplano. So you can walk like you're walking outside the plane. But when the plane takes off, you have to put the seat belts on because the plane is still accelerating. So when the seatbelt indicator is turned off, pwede mo na tanggalin ang seatbelt, and if you want to go back to the toilet, so you can go back. So this time, the plane is already flying. But still, pwede ka maglakad sa loob ng eroplano as if you are just walking outside the plane. So walang pagkakaiba sa sensation when you are walking while the plane is on the ground and while the plane is flying at a constant speed. Then, ang pangalawang postulate, the speed of light postulate. So the speed of light in a vacuum is always the same. The speed of light is always constant at 299,792,458 meters per second or 186,000 miles per second if it is in the vacuum of outer space. Pero bagyong nag-iiba po ang speed of light whenever it travels through medium like water or air. Alright. So general relativity, this is a theory of space and time which was published by Albert Einstein in 1915. So iba po ang general relativity sa special relativity na paksa po natin sa nakaraan na linggo. The central idea of general relativity is that space and time are two aspects of space-time. So space-time is curved when there is matter, energy, and momentum resulting in what we perceive as gravity. So the curving of space-time controls how the objects in the fabric of space-time moves. Sa kalawakan, ang mga bagay na kagaya ng mga planeta, mga bituin, ay may gravitational field. And this gravitational field can create curvature in space-time. Ang planet Earth ay may taglay na gravitational field, which means that the planet Earth can also curve space-time around it. So we can call these gravitational wells na maihalintulan po natin sa isang balong malalim. So the bigger the mass the object has, the deeper the gravitational well will be. So ikumpara po natin, mas bigger in mass ang Jupiter and Earth is smaller in mass, so therefore Jupiter has the bigger gravitational pull, hence having also a greater, deeper gravitational well. So paano po natin mailalarawan ang space-time sa isang bagay na mas madali nating maintindihan? Alright, so let us view this short video clip in the next slide.
Essential ideas. So, Einstein wants to know how the force of gravity works, how the sun communicates the pull of gravity across empty space to the Earth. Here's the idea he comes up with. He says that the fabric of space is nice and flat if there's nothing there, no stars, no planets, which would mean that if an object rolls through that environment, say this is a comet or a planet, it will go in a nice straight line trajectory. But the key thing is Einstein says that if we have a heavy, massive object like the sun, Einstein says that the sun, merely by being within the fabric of space, causes the fabric to curve, to warp. And then other objects, like the planets, the Earth, Mars, and so forth, he says, they go into orbit because they're rolling along the curved environment that the sun creates. This, according to Einstein, is how gravity is communicated from the sun to the Earth, to Mars, the other planets. This is how gravity works.
All right. So sa halimbawa na nailarawan dito sa ating short video clip, mahihalin tulad po natin ang space-time fabric sa tela na kagaya ng nasa video. So if there is a bigger mass in space, the smaller mass can go travel in a straight line. And if we add a bigger mass in the fabric, so it will create a curve in space-time fabric, gaya ng sa ating solar system. So how massive or how big the mass the object is yun po ang lalim ng gagawin sa bagay o tela, which we can compare to the gravitational well. Right.
Essential idea.
So now let us discuss the different consequences of the general relativity. Ang general relativity ay teorya na nakafocus sa gravitation. So it focuses on gravitation. So as I have said, it is different. It is very different to the special relativity theory, in which the focus is the inertial frame of reference and speed of light. So one of the consequences of the general relativity is the orbit of Mercury. So quick facts about the planet Mercury. So all the planets in the solar system are named after Roman gods. So in Roman mythology, Mercury is known as the quick and agile messenger to the god. And ang planetang Mercury ay siyang pinakamalapit na planeta sa araw. At dahil dyan, ito rin ang planetang pinakamabilis makumpleto ang isang buong cycle. So it takes only 88 days for Mercury to orbit around the sun. Right? So sa lahat ng planeta sa solar system, ang Mercury naman ay ang may pinakakaibang orbit. So Mercury's ellipse never close. So paano po nagagawa ng Mercury ang kanyang kakaibang orbit? Alright, so let us view again another short video clip.
An ellipse, But it did something weird. It had something called a precession. What this means is that its ellipse never closes. The point of the orbit that was farthest from the sun advances a little bit every time Mercury goes around the sun. It's as if the ellipse itself is orbiting the sun. No one could ever figure this out using Newton's equations. When Einstein applied his new curved space theory to this orbit, the new theory predicted exactly the precession that Mercury actually has. Finally, a theory perfectly matched the observation, which had been a mystery for decades. You can only imagine how Einstein felt in an ellipse, but
Right.
an ellipse.
All right, so this is the precession of Mercury's orbit. So the furthest point of the planet away from the sun, its aphelion would seem to advance a bit every time it goes around the sun. So the same goes with the perihelion, or the point closest to the sun. Kung titingnan po natin ang orbit ng Mercury, parang ang ellipse pumapalibot po sa araw. And the next consequence that we will discuss here is the gravitational bending of light. So our earlier examples, illustrate that massive bodies can create a curve in the fabric of space and time, gaya na nakikita nyo po dito sa slide. So kahit ang liwanag ay sumusunod sa curve ng space-time o ang gravitational well na likha ng gravitational field ng massive bodies in outer space. Sa illustration na nakikita nyo po sa inyong mga screen, ay ang direksyon ng liwanag mula sa star ay bahagyang bumabaluktot at sumusunod sa space-time, sa curve ng space-time na gawa pa ng isang star. Right. So dahil sa bending, ay nakikita natin ang kinalalagyan ng star sa kalawakan ay hindi nito ang actual nitong kinalalagyan. Alright. So this is how we view the star when in reality, okay, dito po yung actual position ng star. So we are seeing the star in its position because of the gravitational bending of light. And as the light bends, time slows down. So as the light overcomes the gravitational well by the massive object, light undergoes gravitational shift. So ano po ang nangyayari sa gravitational shift? So we all know that light is an electromagnetic wave, okay, shown in the slide with the following properties. All right, we have the crest, the throw, the wavelength, and the frequency. So the crest is the point on the wave with the maximum value of upward displacement. And the throw is the opposite of the crest. So when it is undergoing redshift, the wavelength, okay, the wavelength, which is the distance between two waves, becomes longer and the frequency decreases. So humahaba ang distance between these two waves, which is the wavelength, and the frequency decreases. Right. So that's what happened in a gravitational redshift. So dahil po electromagnetic ang isang light, so the light waves undergoes increasing wavelength. Okay, when the wavelength increases, makikita po natin lumalayo po ang distansya ng bawat wave from each other. And hence, the frequency decreases. And another result of the general relativity theory are the black holes. So ang nakikita nyo po sa larawan ay ang imahe po ng isang tunay na black hole. So a black hole is one of an unbelievable gravitational pull, and because it has a very tremendous mass. So dahil sa taglay nitong napakatinding mass ay mayroon po itong napakalakas na gravitational field. So sa lakas ng gravitational field ay maaring walang makawala mula rito, not even light can escape from it. So, ang isang kutsara na matter na galing sa isang black hole ay maaring maging kasing bigat ng buong Mount Everest. So, ang mga black holes po, okay, they are very small in size but the mass are very compacted. So, paano nga pala nakikita ang mga black holes? Dahil nga pati liwanag ay hindi po nakakatakas dito. So kapag napalapit po ang isang star sa isang black hole, so all of the matter from the star gets sucked into the gravitational field of the black hole. Right? So in every galaxy, there is a black hole at the center. So ito pong black hole na ito, this influences the movement of the other bodies within the galaxy. So our galaxy, Milky Way, has a very massive black hole at its center. So all the stars within the galaxy follows an orbit around the massive black hole at the center of the Milky Way. Okay, pati ang araw ay nasa loob po ng Milky Way at ito po ay lumilibot sa black hole na sentro sa ating galaxy. So our solar system is located, okay, according to this representation, okay, andito po located ang ating solar system. So the supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. So it has a mass of equal to 4 million suns and would fit inside a very large ball that could hold a few million Earths. So the question, mahihigop po ba ng black hole ang ating solar system? So the question is, dahil napakalayo po natin from that black hole, malayo po ang possibility na mahigop tayo, okay, by the gravitational field of that black hole. Dahil napakalayo po nito, okay, napakalayo po ng black hole na ito. So the light coming from the center of the black hole can reach the Earth after 25,000 years. Right? So at the start of our tutorial, we had mentioned that the mass of an object can curve the space-time fabric. So dahil po napakalakas ng gravitational field ng black hole, para pong balong malalim ang space-time fabric. Okay, that is because the curvature is strong and nothing comes out of a black hole, no light, no radio wave or whatsoever when matter, okay, goes past the event horizon. So ito po yung event horizon. So according to the general relativity, okay, time slows down and eventually stops as one approaches the event horizon. So what happens beyond the event horizon? So no one knows. Physics has never been able to answer that question yet. Right? Let's proceed to the gravitational waves. Right. So a gravitational wave, okay, these are formed when, okay, when a supernova, two big stars orbit each other and two black holes orbiting each other and merging. So this merging causes powerful gravitational waves. Right. So these are the instances wherein a gravitational wave is created, right? A supernova explosion, a supernova. Okay, big stars orbit each other and merging of two black holes. So in 2015, scientists detected the gravitational waves for the very first time. So they used a very sensitive instrument called LIGO, or Laser Interferometer Gravitational Wave Observatory. So these first gravitational waves happened when two black holes, okay, crashed into one another around 1.3 billion years ago. So the ripples only reached Earth in 2015. Right? And now we proceed to the last topic, how we know we live in an expanding universe. So what causes the Big Bang? Meron po bang mga, okay, what was there before the Big Bang? What evidence do we have for the Big Bang? When we say the universe is expanding, what exactly is expanding? So before 1917, many scientists thought the universe always existed. But the revolutionary theory of Einstein, or the general theory of relativity, so changed all the rules, and it opened up to the possibility that space is actually expanding. So if the space is expanding, the universe that we live today could have been smaller. And in 1929, Edwin Hubble made the amazing discovery that distant galaxies are moving away from us. So, which means that the galaxies we see today are much closer together years ago. Right? So, Father George Lemaitre, a Belgian astronomer, cosmologist, and a Roman Catholic priest, formulated the Big Bang Theory. So according to the theory, nagsimula po ang universe sa isang napakaliit na super atom. So napapalo po sa graphics na ito ang kasaysayan ng universe ayon sa Big Bang Theory. So ayon sa teoryang ito, ang universe ay nagsimula 15 billion years ago. So 15 billion years ago, the universe started as a singularity. So the universe began as an infinitely hot and dense initial singularity. And then, in a few nanoseconds from the beginning of time, the universe expanded rapidly in what is known as the inflation. So, in inflation, the expansion of space was faster than the speed of light. Kaya, very exponential ang expansion ng sinaunang universe. So, it only happened nanoseconds after the beginning of the universe. So, in the human perspective, napakabilis po ng mga pangyayari. So, as stated in the slide, the expansion of space started after nanoseconds, or 10 to the negative 36 power of a second. So, this is faster than, okay, closing our eyes or blinking of our eye. So, nagsisimula pa lang mag-expand ang universe, so it was still very hot and very dense. And in that period, matter and antimatter were formed from energy, but keeps on destroying each other in what we call as annihilation. And so, in only 1 second, the exponential expansion of the universe has resulted in its expanding million times its original size. So that's how exponential the expansion of the universe was. Okay, 1 second after the Big Bang. And as the universe expanded, bahagyang lumamig ang universe from its very infinite temperature, and the quarks finally came together to form protons and neutrons. And 3 minutes after the Big Bang, these protons and neutrons form the light elements by nucleosynthesis. So the first element the elements formed 3 minutes after the Big Bang where hydrogen, helium, and electrons bind to these ionized proton and nuclei to form neutral atoms in a process called recombination. So that was 3 minutes after the Big Bang. And photons or light is no longer scattered and can now freely move in space as the period of the dark ages of the universe. So at that time, no stars were formed. So no stars were formed at that point in the history of the universe. So about 400 million years after the events of the Big Bang, stars start forming. So how are the stars formed? So gravity. Okay, it is the gravity. Gravity caused the atom to collapse onto one another. Gravity caused the light elements to form a single mass and ignite nuclear fusion. And as a result, more stars and galaxies are formed. And after that period, the universe is still expanding and cooling further. May mga katibayan na sumusuporta sa Big Bang Theory. Okay, some of these are which we call the relative abundance of the light elements. So these light elements are the first elements that were created during the first stages of the Big Bang. And these include the hydrogen and helium, or the first two elements in our periodic table. So element 1 and element 2. In the universe, ito po ang composition ng ordinary matter. So 24% helium, 75% hydrogen, and 2% of other elements. So bakit light elements lamang po ang na-form during the Big Bang? Alright, so it is because the heavier elements found in the periodic table are formed in the core of the stars. And these elements are only dispersed across the universe during a supernova. The other evidence supporting Big Bang is energy left as a result of the recombination of the positive nuclei and electrons. The thermal radiation is seen as a faint microwave glow emitted in space as observed by the instruments. Right. So there are several misconceptions associated with the Big Bang Theory. So let us clarify some of these misconceptions. So Big Bang is the beginning of the whole process called the Big Bang model. And the Big Bang is not an explosion. Okay, remember, the Big Bang is not an explosion of the singularity. Rather, it is the exponential expansion of space during the first moments of the Big Bang. Big Bang does not explain what caused it. So it does offer no explanation as to what caused it or how the singularity came from. So because it is just theory, it is still a work in progress. And scientists are still finding evidence for it until now. Right. And that's it for the school year 2020-2021. Sana po ay naging malaking tulong ang ating mga ETUlay sessions dito sa DepEd Edtech Unit para mas maintindihan nyo ang aming mga minamahal na mga mag-aaral, ang inyong mga self-learning modules. So we are on this same ship. We've been in this journey. So despite the challenges, we've sailed on. Maraming salamat po sa DepEd Edtech Unit, kay Sir Mark Anthony C, kay Sir Mark Anthony Hamisal, at sa lahat ng personnel ng DepEd Edtech Unit. Maraming salamat sa lahat ng ating mga ETUlay tutors na nagsakripisyo ng kanilang oras para lamang maitulay ang kaalaman. Maraming salamat sa ating mga mag-aaral na walang sawang sumusuporta sa ating mga ETUlay sessions. Ito po ang inyong tutor sa Senior High School Physical Science, Tutor Lester. Congratulations sa ating mga batch 2020-2021 graduates. Sa ating mga mag-aaral, kita-kita po sa susunod na pasukan. Mabuhay po kayo. Tutor Lester, now signing off.
Sigurado ako na marami ka na namang natutuhan sa ating ETUlay tutorial session ngayong araw. Tandaan, ito ay hindi lamang para sa ating mga mag-aaral, kundi pati rin sa ating mga minamahal na guro at mga magulang na kaagapay natin para maituloy ang pagkatuto sa kabila ng nararanasang pandemya. Patuloy ding sumubaybay sa DepEd TV para sa mga araling ginawang video episodes. Mapapanood ito mula Lunes hanggang Sabado, alas 7 ng umaga hanggang alas 7 ng gabi sa inyong mga telebisyon. Abangan bukas mula 1:00 ng tanghali ang iba pang aralin sa ating ETUlay free online tutorial session sa English. I-like and subscribe at manatiling nakasubaybay sa ating ETUlay tutorial session sa DepEd Edtech Unit FB page at Educational Technology Unit channel sa YouTube at sa DepEd Tayo at DepEd Philippines social media accounts. Paalam!